Hello everyone, and welcome to our second lecture on hallucinogens. So last time we talked about hallucinogens. We'll continue that today. And last time we talked about how to classify them. And so they're classified, as we discussed, both by their effects and their structure. So last time we just mainly did the classification and talked about LSD, which is an indole hallucinogen. That's a structural designation. And we'll actually cover the rest of them today. Many of them have effects very similar to LSD, and we'll notice the differences. We'll also continue to talk about how hallucinogens work. Most of them, at least the Fantastica hallucinogens, work through the serotonin system. Now, the indole hallucinogens seem to do this directly. The catechol hallucinogens seem to do this indirectly, but the effect is very similar. The behavioral experience is pretty similar for both kinds. We'll also wrap up today talking about how hallucinogens have affected society, what society's perception of them is on average. So in particular, we'll talk about the indole and catechol hallucinogens. So we started talking about the indoles last time with LSD, and we'll finish that up. We'll also talk about the dissociatives and the deliriants. Now remember, your book puts PCP and ketamine in the deliriant category, and that's not a common thing to do. So I've kept them in a separate category called dissociatives. We'll also talk about the regulatory status of hallucinogens. Many of them, most of them, are on Schedule 1. We'll talk about research, and we'll talk about trends in usage. So psilocybin is another indole hallucinogen. So it comes from a mushroom called Psilocybe mexicana. These are often called magic mushrooms. There are actually a variety of species of mushroom that have psilocybin in them, but this is the most famous, the most notable. And as I said, it's an indole hallucinogen, so it's in the same class as LSD. So indole is that chemical group you see here in this figure from your book, and you can see how psilocybin here on the right mimics that two-ring structure, the 6 carbon atoms, and then the 4 carbon and 1 nitrogen. And of course, the indole group is characteristic of serotonin, or 5-HT. So psilocybin has an effect on mood, perception, and thought, just like LSD is, or does. Psilocybin seems to affect mood a little bit more, for reasons we don't quite know. As with LSD, there is the possibility of panic or anxiety. The long-term chronic effects of psilocybin use aren't entirely clear. There don't seem to be any glaring negative effects. Psilocybin users do report spiritual or otherwise sort of supernatural experiences, and those experiences actually seem to last for a while, can even last for months. Not the perceptual alterations, but sort of a generalized feeling of spirituality seems to be enhanced over the course of a long period of time. And so not surprisingly, psilocybin mushrooms have a history of religious use. So in other words, as entheogens, which is something we talked about weeks ago, these are drugs that are used to enhance or create a spiritual experience. You can see the word theo in the middle there, just like in theology, and gen, that is creator of, generator of. So it creates a spirit within. So it's a religious experience. And this has been used by Native Americans for centuries, particularly in Central America, where the mushroom hails from. And a lot of hallucinogens have been used in this manner. That's something we'll see over and over again. Now, of course, many of our hallucinogens are synthetic, so those don't have a long history of religious use, but many of them are naturally occurring. And even the synthetic ones are often derived from natural products. So some of the other indole hallucinogens, there is N in dimethyltryptamine, otherwise known as DMT. And so this is native to South America. And it's a naturally occurring substance. And normally, DMT is metabolized by monoamine oxidase, which is an enzyme we've come across before in our chapter on psychotherapeutic drugs. Remember, we have a class of antidepressants called MAOIs, monoamine oxidase inhibitors. So the same enzyme usually degrades DMT to where it's no longer active. But a South American beverage used traditionally by native peoples called ayahuasca contains another substance that inhibits monoamine oxidase. So that's how the DMT gets into the system. And I believe at least one of you wrote your previous paper on ayahuasca. So it's a tradition. It's part of a traditional religious ceremony. DMT itself actually doesn't last that long in terms of its effects. It's sometimes referred to now as a businessman special because it lasts for about an hour, the effects wear off, and you can go about your business. This is in contrast to something like LSD or psilocybin, which lasts for hours. One hallucinogen your book doesn't mention is ibogaine. And this is a hallucinogen traditionally used by the natives of West Africa in the area of Ghana or Gabon in religious ceremonies, so used as an entheogen. Interestingly, last time we talked about LSD and its potential as a treatment for alcohol dependence. In a similar vein, it's been suggested that ibogaine could be used for opioid addiction. Now, the research isn't totally clear. There are reports that opioid addicts don't feel the craving for opioids after ibogaine administration. But there are obviously also side effects, as there are with many hallucinogens. So not much research has been done, and there are obviously side effects, which is why many governments are not actively researching ibogaine as a potential treatment, but there is that possibility. So those are the indole hallucinogens, characterized by the indole group, so similar to serotonin. There are also the catechol hallucinogens, which are similar to the catecholamine neurotransmitters. So notably dopamine and norepinephrine. Also epinephrine, but again, we don't talk about that one so much in this course. And the effects are actually pretty similar to indole hallucinogens, which is a little surprising because it's a different neurotransmitter that it's mimicking. But it seems to be the case that whereas LSD, psilocybin have a direct effect on serotonin receptors, that the catechol hallucinogens have a more indirect effect on the serotonin system. So you see a lot of the same effects, but it's indirect. So among the catechol hallucinogens, possibly the most famous is mescaline, which we see here. So again, we see this catechol group, that 6-carbon ring structure, with you see the carbons and the nitrogen on the right side there. Mescaline is the psychoactive ingredient in peyote. Peyote is the name of the cactus from which mescaline is derived, and mescaline also has a history of religious use. And we talked about this early on in the course, talking about regulation, because there are some states have made exceptions for peyote use among Native Americans because it's part of their religious ceremony. So it is a hallucinogen, and it is not without its side effects. So again, we had a discussion about whether it was appropriate to make an exception in that case. We have freedom of religion up to a certain point, but we also have laws designed to safeguard the public when drugs have dangerous side effects. So we've already had that discussion. We won't have it again this week. We have other discussion questions for this week. But that is one of the main drugs over which this debate is occurring. Also in the catechol hallucinogen group are the amphetamine derivatives. And there are several hallucinogens in this category. So again, here we have the basic catecholamine neurotransmitter, so we have dopamine. And we've already seen how amphetamines and methamphetamines mimic this structure and seem to affect the dopamine and norepinephrine systems in particular. So one of the most famous amphetamine derivatives that's in the hallucinogen class is, it's a mouthful, it is 3,4-methylene dioxymethamphetamine, or MDMA. And there are others as well. There's DOM, MDA. We're not going to go into all the acronyms. I will just use MDMA as a representative of this category. And of course, MDMA is also known as ecstasy. So this is a relatively recent drug of recreational use in the hallucinogen category. So it is synthetic. When it's taken, it seems to foster a sense of euphoria and also sociability. So people are supposed to be more empathetic, they're more interested in socializing, in physical contact. So it's not a hallucinogen in the usual sense of altering visual perception. It's classed with the hallucinogens because it seems to have a large effect on the serotonin system. The other amphetamines do to a certain degree, but not like MDMA does. And so the hallucinations are not visual in nature. They tend to be things like time distortion and altering body perception. So altering especially skin contact. So it alters perception, just not in the visual domain like the classic indole hallucinogens do. One thing MDMA does is increase body temperature, and this can be actually dangerous. So MDMA is more dangerous than LSD, not as dangerous as some of the other hallucinogens we'll talk about. And it seems to have an effect on sleep, certainly. It disrupts sleep, not unexpected for something related to amphetamines. There's some debate as to what it does to mood. So whether it basically creates a crash in serotonin levels a couple days after use and creates a temporary depression is still a matter of debate. So it was reported fairly early on in research on MDMA that MDMA killed dopamine neurons, not unlike Parkinson's disease. This turned out not to be true. So it turned out that the lab conducting the research was accidentally sent methamphetamine instead of MDMA. So it was well known already that methamphetamine kills dopamine neurons, and so because of the mislabeling, it was thought for a while that MDMA kills dopamine neurons also. That's definitely not true. It might kill serotonin neurons, so the jury is still out on this. It does seem to kill serotonin neurons in mice. It's not clear whether it does so in humans, and it's not clear whether it does so at the usual dosages that are taken by recreational users. So killing serotonin neurons in mice, it takes a relatively high dose compared to what a person would take, normalizing for body size. So the jury's still out on that one, but it is potential. Okay, moving on to the dissociatives. So the dissociatives are different from the Fantastica and from the deliriants. So remember that your book puts PCP and ketamine in the same category as deliriants, and that's typically not what the thinking is. So I'm not going to do that here. I will keep the dissociatives as a separate category. So the famous examples are phencyclidine, also abbreviated as PCP, and colloquially known as angel dust, we see here on the right, and then ketamine, which is also known as special K, and now we see it here on the right. So there's some similarity in structure. You have at least two of these 6-carbon rings. So what do these compounds do? Well, they were originally developed as anesthetics, and they are still used in that way not commonly, but that is still a legitimate use because they are effective anesthetics. Um, so one of the things it turns out they do, and this was not discovered until later, is that PCP and ketamine can affect memory. So it's not just an anesthetic, it's that you lose your memory, that is to say you actually never form a memory of the procedure. And this happens because PCP and compounds like it affect NMDA receptors, which if we recall from our unit on the brain, NMDA receptors are ionotropic glutamate receptors, and they're important particularly because they seem to be involved in memory, that they're involved in long-term potentiation, which is how it's thought the brain forms memories. And so if you block those NMDA receptors, you're blocking glutamate activity, but you're also blocking the ability to create LTP and form new memories. In addition, PCP is an effective analgesic, as is ketamine, and it turns out, after a lot of research, that PCP, there's a receptor, an opiate receptor, that seems to be specific to PCP. Now, PCP is not an opiate, so there's been debate about renaming this class of receptors. Nevertheless, it does seem to bind readily to this receptor, and that's how it blocks pain. Now, of course, PCP is a synthetic compound, so it's unlikely that this receptor evolved to bind to this newly developed compound. There's probably a naturally occurring substance within the body that binds to that receptor. It's the case for all the other ones, so probably for this one too. Uh, in addition to analgesia, the dissociatives can also create a sense of distance from reality, which eventually, in extreme form, can be a form of psychosis. And of course, psychosis typically involves the dopamine system. And so this is a dissociation from reality, hallucinations. For schizophrenia, they're typically auditory. The dissociatives create all sorts of psychotic symptoms and can create those symptoms even after use of the drug is stopped. So this can persist for a while. In terms of the long-term effect on the brain, PCP is neurotoxic. So in addition to its other effects, prolonged or heavy use does actually kill those glutamate neurons. So you can get lesions in the brain because glutamate is the glutamatergic neurons are the most common kind of neuron in the brain. Killing those neurons represents a significant portion of the brain's real estate. So killing off those NMDA receptor expressing neurons can result in a serious loss of function. There are also, of course, stories involving PCP users that run afoul of the law, and there are stories about these people being shot several times and not seeming to be affected by it. Those are probably apocryphal. However, trying to control someone who's on PCP, they're not really aware of reality in the sense that you and I are. So their perception is distorted. Also, they're on an analgesic. So using pain as a deterrent isn't going to work on someone who's on PCP. All in all, PCP is probably one of the most dangerous hallucinogens. The deliriants that we'll talk about next are also dangerous because of their effects on the cardiovascular system, on body temperature. But PCP has direct neurotoxic effects. It's best avoided. It's thankfully not all that popular. And never was, but certainly now isn't. Moving on to the deliriants. So these are mostly natural occurring substances. One of the most famous is belladonna, which contains the deliriant called atropine. There's also mandrake, which contains atropine among other compounds that have a similar effect. Mandrake you may have heard of because of the Harry Potter movies. So it's so named because if you squint, it looks like the plant itself is a root, and it might look like a person. It has multiple roots that kind of stick off and look like arms and legs. So that's why it's has a long-standing connection to medicinal use and religious use because people thought it was some form of person. Anyway, nowadays we probably know of it because of Harry Potter, but it contains atropine and some other related compounds. And there's also Amanita muscaria, which has also been called fly agaric. It's a mushroom. It's a poisonous mushroom. And it is one you probably best stay away from. It's one of those mushrooms that people eat thinking it's an edible mushroom. Uh, they can they can suffer the toxic consequences fairly easily. So how do these compounds work? These are different from the Fantastica and from the dissociatives, which is why dissociatives belong to a separate category. Deliriants work by blocking muscarinic receptors. And these are a kind of acetylcholine receptor. Now, acetylcholine is not a neurotransmitter we've talked about this week so far. But of course, acetylcholine is involved in muscular function, but it's also involved in things like memory. So it is present in the brain. What this ends up doing for our purposes is it basically blocks the parasympathetic nervous system. Remember, the sympathetic and parasympathetic nervous systems are responsible for our flight or fight response. That's the sympathetic. And then the parasympathetic is the rest and digest. So if you block the parasympathetic, you're basically locking the body into fight or flight mode. So you get dilated pupils, you get increased heart rate, you also get increased body temperature, which is one of the reasons this is a fairly dangerous class of compounds to use recreationally. They can be used for the cardiovascular system if they're used properly, but recreationally they're pretty dangerous. So belladonna has its name because it blocks the parasympathetic nervous system, dilates the pupils, and ancient peoples figured out, and we know now, that if you look at photographs of people, of faces, the photographs of the more dilated pupils are rated as being more attractive. And so belladonna means beautiful lady in Italian. So it was used not recreationally per se, but as sort of a cosmetic in the more ancient world. So you get this dilation of pupils, which is, again, a telltale sign, like it is for LSD and other hallucinogens. But you also get this increase in body temperature, and because these compounds also prevent salivation and, more importantly, perspiration, you can actually damage your body by overheating. So you can get a temperature of 108 degrees, and since you're not sweating, you're not losing any body heat. So that's a very dangerous possibility, but a very real possibility. Behaviorally, they're called deliriants because they create a sense of confusion. It's sort of a disconnection from reality, but they're in the hallucinogen class because of this sense of confusion, this loss of touch with the real world. Oftentimes, the user gets a sense of flying. And so last time we talked about LSD and the ergot alkaloids and their possible involvement in stories about witches and other supernatural events. The deliriants are possibly responsible as well. So people that were accused of being witches may have been recreational deliriant users. So they create the sensation of flying. They can block memory, so the person accused of witchcraft couldn't defend their actions, couldn't account for their whereabouts. And the whole witches riding broomsticks thing may have come from the fact that these compounds could be administered using a stick. And I will leave it to your imagination how that would happen. But it possibly gave rise to stories of witches riding broomsticks. So again, a little bit of history with our naturally occurring hallucinogenic compounds. Okay, now the status of hallucinogens. First, the regulatory status. Most of these things are on Schedule 1, which means they have a potential for dependence, which doesn't really seem to be the case. Again, our use of the drug schedules doesn't always conform to the original guidelines for what fell into what category. Nevertheless, there aren't any accepted medical uses, um, and there are some potentially dangerous side effects. Less so for LSD, more so for MDMA, and a little bit mescaline. But a lot of these are on Schedule 1 mainly because they don't have a medical use. Schedule 2, PCP, despite the fact it's one of the most potentially harmful, is on Schedule 2 because it has legitimate medical use. It is still an anesthetic. It's not commonly used, but it does still have a medical use in that sense. Ketamine is on Schedule 3. It's used by veterinarians as well as physicians because, again, it has a medical use. Things like atropine aren't actually scheduled at all. And this is true for a lot of naturally occurring compounds. Atropine does have a variety of medical uses, so that is probably why it's not scheduled as a drug of abuse. In terms of research, we've already mentioned the secret research done by the military and the CIA in the 50s and 60s, which was a huge breach of ethics. And partially because of that, partially because of recreational use and poor methodology in studying hallucinogens in the 60s, there really hasn't been much recent research. And now scientists like Roland Griffiths have suggested that maybe we should look at hallucinogens a little more carefully, a little more scientifically, that there may be valid uses for them, especially for things like palliative, that is, end-of-life care. Obviously, there are allowances for religious use, but some possible therapeutic uses have been proposed. We've already talked about using them as treatments for dependence. It's also been shown that perhaps a drug like MDMA can be used to treat PTSD. The two big acronyms there. And it's an unfortunate consequence of what happened in the 50s and 60s, both in terms of secret research and irresponsible research by people using it as a psychedelic, as a way of trying to gain insight, but not in a controlled setting. As an offshoot of that, we haven't done as much research as we have on the opioids or marijuana or alcohol. And so we may be missing some potential therapeutic uses for the hallucinogens or related compounds. And of course, the question is, why does research continue to be fairly minimal with hallucinogens? And opponents to hallucinogen research basically say, well, we sort of know what these compounds do. There are a lot of potential side effects, especially for the deliriants and the dissociatives. And as happened in the 60s, some researchers are concerned that doing additional research on hallucinogens will in some way legitimize their use, and that we'll see a resurgence in hallucinogen use like we did in the 60s. Whether that's a valid argument or not is up for discussion, as we'll see. But that is the counter argument. Okay, so who uses hallucinogens? How common is hallucinogen use? And the answer is it varies by which hallucinogen you're talking about. So things like PCP and ketamine are not all that commonly used. Recently, MDMA, ecstasy, has been the most common hallucinogen. And again, MDMA has some hallucinogenic properties, but it's also different from the indole or catechol, sort of classical hallucinogens. Nevertheless, MDMA saw its peak in around 2001, where about 12% of high school seniors reported using in the last month. So that's our definition of a regular user, even if it was just a one-time use. If you use in the last month, that is how we categorize regular users. It has since dropped off to around half of that, but it's still the most popular. The other hallucinogens, psilocybin, mescaline, PCP, on average, each one is about 1% of high school seniors say that they've used that substance in the last month. So basically add up a couple of 1%, and that gives you a picture of the current level of hallucinogen use. So certainly not as common as alcohol, marijuana, nowhere near as common as tobacco, um, but it's not entirely gone. It is uncommon in anyone over the age of 30 to be a hallucinogen user. It seems to be more common in adolescents and individuals in their 20s, and sort of tapers off after that. And of course, none of this counts religious use. And as we've already discussed, certain Native American tribes are allowed to use, particularly peyote, as part of their religious ceremonies. One of the big problems with hallucinogens is purity. So there are often adulterants in the hallucinogens, and sometimes they're entirely adulterants. So a study looking at MDMA found that only about 40% of pills that were bought under the impression that they were ecstasy, only about 40% of the pills are pure MDMA. Of the remainder, some are adulterated MDMA, and some have no MDMA at all. Similarly, about half of all the LSD that's sold is not actually pure LSD. And of course, anytime you have a drug that's not pure, you're running an additional risk because you don't know what's in it. You don't know what the dosage should be. And many times these are not necessarily intentionally put in the compound, but sometimes they're just byproducts of synthesis. So a lot of these are made not by pharmaceutical companies, but by unlicensed home chemists. And so a lot of those byproducts, which are often related compounds, will sneak into the drugs also. And again, here you have an issue of dosage. Some LSD has a very small effective dose. Other drugs, it takes quite a bit more. So anytime you're not working with a carefully manufactured substance, you have this risk, not just from the drug itself, but from the adulterants. Okay, so that will wrap up our unit on hallucinogens. Next time we're going to talk about over-the-counter drugs. So we'll talk about the different types, and of course there are lots. It just takes a visit to your local pharmacy to see there are many kinds of over-the-counter drugs. We'll talk about what they do. So what are the effects, both in the positive domain and the negative, of these different over-the-counter drugs. And we'll revisit dietary supplements, which is something we talked about during our unit on drug regulation, and we'll come back to that in a little more detail. So that is it for this time. I will see you next week.